going to discuss here the bandwidth of the cascade amplifiers. Cascade means one amplifier connected to second and so on. Firstly, we to go for these videos for best understanding. That's very important. And the result of this is for low frequency, and the gain is like this. Gain of the low frequency as compared to the gain of the mid frequency. Then you have to go for the second video for the high frequency, and this is the result. Again, the gain of the high frequency relative to the gain of the mid frequency is equals to when stages are cascaded means one is connected to second connected to third, the bandwidth is always reduced. We assume here that the stages are isolated and their connections in cascade does not alter or affects the definitions of F1 and F2, low frequency and high frequency, for bandwidth. This is because assumption, but this will be true only if the output impedance of each stage is very, very low and input resistance of each stage is very, very high. Then the assumption may be true. Okay. First we consider the high frequency, which is F2, and we know the result. This is the result for the high frequency. Now, if we are having the two in cascade, then the gain gets multiplied. This is the principle of cascading. The voltage gain always gets multiplied. For 3 stages, again the multiplication of the 3. Now it is our assumption that F2 of any stage, it is the same. F2 is same like of first stage, and it is second and third, they all having same F2. And if they are the end stages, then the gain is like this. Now we are defining another F2 average now, another frequency, very important. Like this is the limit frequency of the complete design of the complete amplifier having the end stages. F2 average is for the complete design. Okay. And F2 average is that frequency where the total relative gain becomes the root of 1 over under root 2. Relative gain of the whole system. Okay, now what we are doing, we are substituting this condition here and changing F2 as F2 average, changing F as F2 average, changing F as F2 average. So with this, now we are simplifying and we will get the value of F2 average. Mean we are finding that frequency, that average frequency, which gives our result, total results. The relative gain becomes the 1 over under root 2. So just simplifying now. Look, the simplification. So this is the last expression of F2 average. F2 a root of 2 raised to power 1 by n minus 1. So cascading makes F2 average lower than that of F2 of a single stage. This is the result. Very important. Now we consider the lower frequency, which is F1, and we are having the result already. This is the result relative frequency for F1. Using this result here, and if we are having the n stages, then again the gain gets multiplied and multiplied raised to power n. Now we define F1 average. Again the definition is same. When the relative gain of the whole system, whole amplifier, becomes 1 over root 2. So this is 1 over root 2. This F is called F1 average. F is called F1 average. But you know the whole raised to power, n also, because we are using n stages. Now simplifying it, we find from here F1 average. So F1 average becomes F1 divided by root of 2 raised to power 1 by n minus 1. So with the help of new values of F1 average and F2 average, the bandwidth becomes narrow. So this is the results of the cascading. Now our assumption was stages are isolated and having the same value of F2 and F1, but it never happened like this because it was under the condition input impedance is very high and output impedance low. But in general, if F2 are different of each stage, then the relative gain of the cascading becomes like this. Okay, fine. Thank you.